All right, hello everybody. This is the first part of the video for section 2.1. So really starting to dig into chapter 2 now. And just moving right along. Time flies when you're having fun in a math class, right? Yeah, I know that's how you feel. Okay, so section 2.1 is our first one on linear functions. And before I get into some of the details of what that is, let's look at an example. Just to kind of get us started with understanding why these might be important. So we're told that the queen of pop music, who is obviously Beyonce, and no, I will not argue that fact with you, it's just a fact, currently has a net worth of $355 million. And each year her net worth is increasing by approximately $5 million. Now you notice down below I have a couple of questions about can we determine her net worth in 8 years? And how many years will it take for her net worth to reach $430 million? And maybe you could, use the fact that we know she's starting with 355, adding 5 per year. You could answer each of those questions. But I want to do this using a linear equation, okay? So first thing we're going to do here in the first question is write an equation that describes her net worth, which we're calling W, after T years. And we're assuming the starting year is when she has $355 million. Well, I imagine that most of you would agree with me that we could write an equation that looks something like this. W equals 5T plus 355. Okay, and let's analyze where this came from. First of all, because the 5 and the 355 are both in terms of millions, I did not write out those full numbers, so I can use the abbreviations there. Also, the 355 is what she starts with, so that's why I'm taking her total worth, whatever it is, and just adding 355 at the end. And then because she earns $5 million per year, here I have a 5 times the number of years, because she would, for each year that passes, earn an additional $5 million. So if we multiply those numbers, number of years times 5 million, added 355, that'll give us her total worth. Okay? Well, then the second question says, now that we have that, can we use that answer to determine her net worth in 8 years? And hopefully you're saying, well, yes, Cody, we can, because that 8 years, that's amount of time. And in our equation, T, the variable T stands for years, or stands for time. Okay, and in this case, we've got T equals 8. So we can just input that into our formula there. So we have W equals 5 times 8 plus 355, which if we do that, looks like we would end up with $395 million, I do believe. Okay, because the 8 times 5 is 40, plus 355 is 395, so $395 million would be her net worth after 4 years. Okay. Third question asks, how many years will it take for her net worth to reach $430 million? Now this question is a little bit different than the previous one in that now we have that $430 million, which is a value for W, right? It stands for the net worth. So we can take that now and plug it into our equation, but this time that will go in the place of W. So we'll have 430 equals 5T plus 355. We can solve for T there. Okay, so we could subtract 355 from both sides. Okay, when we do that, then we'll end up with, I'm going to have to erase that W. 430 minus 355 is 75, I do believe. So 75 equals 5T. Then we can divide by, oh Lord, sorry, hit the wrong button. We can divide by 5 on both sides. And when we do that, we end up with T equals 15. And in this case, our units are years. Okay, so assume she keeps earning money at the same rate. Her net worth will be $430 million after 15 years. Okay. I went over this problem for a couple of reasons. First one, so we could see how linear functions or linear models can be used in real-world situations, but also to highlight that in the second and the third question, in each case, we were given some value. We had to figure out what it went in for in the equation, right? So on this second one, we had the 8 years, so we put that in for the value for t because it was a time. On the third one, we were given the $430 million, which was a value for the net worth, so that went in for W. So that's something you'll want to keep in mind as you're working through problems in this section and in this chapter. Okay, so as I mentioned, a linear function is what we're looking at in this section. And as it says here, it's a function whose graph produces a line. We've seen that before. And then we're told that linear functions can always be written in the form f of x equals b plus mx, or you're probably more familiar with f of x equals mx plus b. Now, I do want to caution you, and I've said this before, that the only variables out there are not just x and y or x and f of x, right? So here it says f of x equals mx plus b, but like if you were looking at the one we just looked at, instead of f of x, we had w, and instead of x, we had t, but there was still an m value and a b value, okay? And those, as it says here, the b starts for your initial or starting value of the function. And note that it also says that's when the input x equals 0 or t equals 0, whatever, right? And hopefully you can see that in what I've written here, because regardless of what m is, if t is 0, right, we'd have w equals m times 0 plus b. Well, m times 0 is just going to give us 0, plus b gives us w equals b, which then gives us a point 0 comma b, right? Because our input value was 0, which led to an output value of b. So that's another way to think about b. Also, the value for b, because it's at the point 0b, you can imagine if we have the graph of a line like this, right? Where is that point 0b going to be? It'll be where the input is 0, which is going to be right there at that point, which you notice that gives us what's called the vertical intercept there. So that's why that value b tells us where we intercept the vertical axis. All right, and then the value for m there, again, regardless of what your variables are, that will always be your constant rate of change. So what makes linear functions special or makes them different than other types of functions is they have a constant rate of change. And we looked at this in our prereq material. Regardless of the interval over which you choose between 2 points on a linear function, you will always get the same rate of change. So that's what makes them so special and so interesting to study. I also noticed, again, up above, they gave kind of two forms for the equation of a line, f of x equals b plus mx, or f of x equals mx plus b. Hopefully you see that they're the same, right? Because you can do addition in any order. 5 plus 4 is the same as 4 plus 5. So b plus mx is the same as mx plus b. And again, the mx plus b is probably more common, but this b plus mx can be helpful way to write things sometimes. Because you can see where the function is starting, because you've got the starting value first, and then how it's changing. So you can use whichever form makes the most sense to you. All right, so let's use that idea now to interpret what some linear functions are telling us. So in the first one here, it says the value in dollars of a 2014 Nissan Versa, t years after it's purchased, is given by v of t equals 11,990 minus 2,000 t. And they want us to tell them what information this is giving us about the value of the Nissan Versa. Okay. Well, we can line up this equation here. I have to write it down below. I apologize. With that form f of x equals b plus mx, right? And I did this way because I see that the variable here is t, so that's going to go with the x. And then that number is being, that negative 2,000 is being multiplied by the variable, so that could be the m. And 11,990 would be the value for b. So thinking about what we were just looking at, what does this tell us? Well, the value of b being 11,990, it looks like that would be our starting value. And notice here that the units there would be $11,990. So that's the starting value. Okay. And then what will the negative 2,000 be? Well, that's our rate of change. And what's it the rate of change of? It's the rate of change of the value of the car. And so what is it telling us? It's telling us the value of the car is changing by $2,000. And because it's negative, that means it's decreasing. Okay. And it's decreasing since the units here are per years. It's decreasing at a value of at $2,000 per year. Okay, so that would be our rate of change there. And one thing to keep in mind when you are interpreting what a linear function is going to tell you, and you're trying to find the units for the rate of change or the slope. So I'm going to clear this out so we can see this a little bit easier. So our value for m here is negative 2,000. Okay. Well, when you're trying to put units on a rate of change, and I mentioned this before, it's always output units over input units. Okay. And in this case, it's probably easiest to see the input units because we see that our input variable here is t, which is in terms of years. So we know that our units here will be years. And then the output, well, the output is the value of the car, which is measured in dollars. So that's why the top units were dollars. So we see that, again, this is the value for m is negative $2,000 per year, which is telling us that the value of the car is decreasing by $2,000 each year. Okay. All right. Next one says Pierce College has started its own ride service to challenge Uber and Lyft. They call it Raider Rides. And of course, you can look this up on your phones later and subscribe to the app. It's growing very fast. We're told that the cost in dollars of a ride of length m miles, and be careful, this m here is not like the y equals mx plus b. Okay, that's actually a variable in the equation. It says the cost in dollars of a ride of length m miles using the services given by C of m equals 3.30 plus 0.5 m. What information does this give us about the cost of a ride with Raider Rides? Okay, so again, we want to line this up, this here, with that f of x equals either mx plus b or b plus mx. In this case, I think we're again going to use the b plus mx. And as I mentioned before, we got to be careful over here. In this equation up above, that m actually corresponds to x, okay, because it's the variable. The 0.5 will correspond to the m here, and the 330 will correspond to b. And we want to think about what do these things tell us. Well, the 330, again, that being b, and it looks like the units there will be dollars. Well, it's the value for b, which means it's our starting value. So in terms of the situation, it means what? Right, it means that there's like a $3.30 initial fee, like when you call the Raider Rides or when you get into the car. Okay, now what is the 0.5 going to mean? This one's sometimes more tricky. Well, it's going to be 0.5. Oops. Actually, let me erase this out. So first of all, it's the value for m, right? It's the rate of change of the slope. So it's 0.5. What are its units? Well, input units here are miles. And what are the output values? Looks like they're costs, which are measured in dollars. So we have $0.5 per mile, or maybe we could write that like this. $0.50 per mile. And what is that telling us? Right, that you're being charged 50 cents per mile for rated rides. All right, so you pay that initial $3.30 and then a 50-cent per mile fee. Okay. All right, last thing here. Integer, who is one of our classmates, I don't know if you've met them yet, has been renting an apartment near campus since 2011. His rent when he signs his lease was $1,000. If the rate of change of his rent over the last 5 years has been 0, write an equation to describe the amount of rent NT will pay T years after 2011. So this is a little different than the one we just did, or the ones we just did, because this time we're being asked to write an equation. So we have to use that f of x equals mx plus b to describe NT's rate, or the information about NT's rent. Okay. Well, we know that m is the rate of change, and we're told here that the rate of change over the last 5 years has been 0, which, gosh, I don't know where NT lives, because nowhere I've ever lived is like that. Times x, which will be our variable. And then recall that b stands for our starting value, and the starting value for his rent was 1,000. So we have 0 times x plus 1,000 equals f of x. But note, okay, f of x equals 0 times x. What is 0 times x? Well, that's 0 plus 1,000 is just 1,000. So we end up with the equation here to describe NT's rent is f of x equals 1,000. What kind of a function is that? Oh, right, from your toolkits, that is a constant function, right? And recall, what does the graph of a constant function look like? Right, again, it's a horizontal line, right? It looks something like this. So what we see are constant functions are types of linear functions. They're just a special type where the rate of change is 0. Okay? All right, so just to summarize some of the stuff we just saw there, like we said, m is that constant rate of change for a linear function. With lines, we have a special name for that. We call it the slope. And the slope determines if the function is an increasing function or a decreasing function, right? So if that value for m is greater than 0, we say that the linear function here is increasing, which hopefully makes sense, right? Because if you think about the example we just did with the rate of rides, when the value for m was greater than 0, when it's positive 0.5, then the value of the ride went up over time, which makes sense because the further you get driven, probably the more you would pay. The function is decreasing if the value for m is less than 0. So example we saw like that was the Nissan Versa one, where the rate of change was negative 2,000. So the value of the car was going down over time. And then if your slope is equal to 0, well, as we saw here, that gives us a function f of x equals b, which is just going to be a horizontal line passing through the point 0b, neither increasing or decreasing. Another way to say that, we know it's going to be a constant function where the graph is a horizontal line, and then we know that for any linear function, the point where it crosses that vertical axis right there is 0b. Okay? All right, that's all for now. Thank you for watching.